Yes.
So let's suppose if we start from the first question. So the first question is for 2 marks that you need to define the radian. So basically, we discussed the concept of radian yesterday when we were talking about the angular displacement. So basically, angular displacement is the angle subtended by the body during circular motion, right? And normally we calculate that, or we can say that we find out that angle in the form of radians, not in degrees, right?
Yes.
So that is the concept you need to write in your answer. So first thing we can say that, so first concept is related to the angle by the body or any object during circular motion. And further, if we want to explain this term, so we know that delta theta is basically the ratio between the length of arc divided by the radius, right? So we can
Yes.
say the ratio of the arc length, radius. So basically, question is for 2 marks, so that's why we just define the concept and just give the reference that how to find out the value or what are the actual value that help us to find out the radian. Okay, if question is for only 1 mark, so you just define with the conceptual that the angle subtended by the body during circular motion, and that angle is known as the radian. Okay.
Yes.
Okay. Now let's move towards the next part. In next part, we are having a mass attached with a string and it is rotating in anti-clockwise direction mentioned in the diagram with constant speed. So a small piece is attached. Okay, the mass is rotating about fixed point p, constant speed. Okay. Now the question is explain what is meant by angular speed about point P of the mass. So they are asking about the angular speed. So basically that is the also basic
Uh,
concept. Yes,
so we will write the rate of change in angular displacement.
yes. So rate of change of angular displacement. So this is the concept of rate of change of angular displacement, or we can say that one more thing. It is the angle swept out per unit time by the string. Okay. So again, the first one is the journal concept, the journal conceptual definition, and second one is related to the diagram. Okay.
Okay.
So this is the second part. Okay. In third part, we are having horizontal flat plate is free to rotate about a vertical axis. You can easily observe in the diagram that was clearly mentioned. A small mass capital M is placed on the plate a distance d from the axis of rotation. The speed of the rotation of the plate is gradually increased from 0 until the mass is seen to slides off the plate. So we just slightly try to increase the speed until that mass slipped out from the right. So the
Yes.
maximum frictional force between the plate and the mass is given by the expression. So now you can see this concept is from AS, right? There is no chapter related to the frictional force in A2. So that's why some topics are included from AS, but they give you some reference over there. So they just give you the value that F is equals to 0.72 W, where W is the weight of the mass that placed on the disk. So basically friction is 0.72 times to the weight of the body. And the distance D is 35 centimeter. Now what they are asking, determine the maximum number of revolution of the plate per minute for the mass to the remain on the plate. Explain your working. So basically some questions are like typical because we are just starting from the first. So some concepts are of the forces and the friction are included from your AS. So once you try to solve one or two paper, so then you are able to understand that how to interact the old concepts with the new one. Okay.
Okay.
So basically this is the whole question. Now any idea how to start the working? So basically, object, if we consider the concept of centripetal force, so what will be the direction of centripetal force in this motion?
It is always
But
perpendicular to the linear speed.
yes, it is always perpendicular to the linear speed. It means it will always towards the center. So this is the direction of centripetal force, right?
Yes.
And the next thing is friction is always like the opposite to the centripetal force, right? Because friction will be always opposite to the motion of the body, right? Or we can say that uh, this body or this object is try to move away from this surface, right? Because they mention in the question that we slightly increase the velocity from 0 until the mass seems to slide off the plate. Okay, so basically friction and the centripetal force both will act in the same direction, right? Because this object tries to move away from the plate. So this will be the direction of motion. Okay, clear? And you
Okay.
know that friction will always in the opposite direction. So what will be the direction of friction? Opposite to the motion. So now you can see that friction centripetal force both are in opposite direction. Sorry, centripetal and friction both are in same direction, and friction is always like in opposite direction to the motion. Okay,
Yes.
clear? Any confusion?
No.
Okay, because we studied the circular motion, so we try to apply the concept with respect to our topic, right? Because they didn't give you the
Yes.
clear concept that these are the values, just calculate the final answer, right? So we need to make our own case. So what we discuss in the that your friction force provides you centripetal force, right? So
Yes.
both will be equal and opposite. Oh, sorry, both are equal. So we can say that there is a equation given in the question. So we can use that value with the help of centripetal force. So we can say that 0.72 W is equals to centripetal force, right? And we know
Yes.
that centripetal force is normally equals to mv square over r. And yesterday we discussed about that concept also. And one
Yes.
formula that we derive, that is equals to mr omega square, right? Normally the centripetal force is
Yes.
mv square over r, that is for the linear, but we are talking about the angular, so we need to use equation b, mr omega square. So we can write it as 0.72 w is equals to omega square, right?
Yes.
And we know that in our question, actually d gives you the concept of r, because d is the radius in this question. So we just replace r with the d, or we can just simply use that value. We don't need to replace it again and again. We know that r is actually equals to d. So we, when we substitute the values, so 0.72, and if we split this formula, so the formula of weight is w equals to mg, right?
Yes.
You can see question is of 5 marks, so that's why it is so much typical, right? So it will be equals to mg equals to m,
Yes.
and the value of d is given in the question, 35 centimeter, or when we convert into meters, so that will be equals to 0.35 omega square, right? And now you can see m and m on both sides will cancel out each other. So finally what you get, 0.72. So these are the values, right?
Yes.
You know that the value of g is constant, that is already given in your answer sheet, just like in AS you observe that in the formula sheet. So all values, constant values are given over there. So you need to find the value of omega. So tell me what will be the value of omega, the final value.
um 0.72 divided by 0.35
Actually, when we multiply with the value of g, so that will be 7.2,
or
right?
10. Yes.
Divided by 0.5. So you need to divide the values and then we just take the under root of it.
Square root.
Okay.
Yes. 4.53.
4.53. Okay. So your final answer will be equal to 4.53 after taking the under root, right?
Yes.
Any idea about SI unit? We are calculating angular speed, omega's angular speed. So your answer
Yes.
will be
2
SI.
SI unit.
So your SI unit will be equals to radians per second, right? Because we are talking about angular speed.
Yes. Radians per second.
Radians per second, because this is first question, so don't take it very difficult. You can take reference from your notes, because when we try to solve time by time, so that will be easy one for you. Okay, now the final
Yes.
thing
Okay.
is again the same. They are talking about the maximum number of revolution. So when we need to find out the maximum number of revolution, so we take the reference like this. So for maximum number of revolution, we can say that your omega will be equals to 2 pi n, right? Why 2 pi n? Because we know that 2 pi n makes, oh sorry, 2 pi makes one complete circle, right? 2 pi gives you the
Yes.
value of one complete circle, and we know that the speed is 4.5 radian per second, right? And they are talking about per minute, right? So in minute, how many seconds are there? There will be 60 seconds, right? So our
Yes.
final working will be like this, that we need to find the n. So n will be equals to omega over 2 pi multiplied by 60. Okay.
Okay.
60 is for seconds because we need to calculate for minute, right? So omega
Yes.
divided by 2 pi multiplied by 60 seconds give you the number of revolution. So you can calculate the final answer.
43.2.
43.2, or we know that we need to round off it, so that will be 43 revolution.
43.
Yes, per minute, right? Okay.
Yes.
So this is the concept of first question. And next they are asking the plate in part B is covered. They are asking about this again, same situation. With mud. Suggest and explain whether mud near the edge of the plate or near the center will first leave the plate as the angular speed of the plate is slowly increased. So now we place mud on the plate, right?
Yes.
So they are asking suggest and explain whether mud near the edge of the plate or near the center will leave the plate. So they are asking about with the reference of radius. So at very close distance or at very greater distance, you need to answer that in which, at which point or with, at what point we can say that on the circular motion, the mud on the plate will leave the surface first. The point near to the center or the point near to the edge of the plate. You may take the reference from your formula also because we are talking about uniform circular motion. And if you remember the concept of angular speed, the angular force, angular centripetal acceleration, so there is a factor. So if we talk about the centripetal force, so you know that centripetal force is actually depends upon or inversely proportional to the radius, right? And
Yes.
according to equation B, we can see that centripetal force is directly proportional to the radius when we are talking about the angular quantities, right? With angular speed. So it means that if your radius is greater, so your centripetal force will be also greater, right?
Yes.
So what we need to write, that at the center it will leave first or at the corner it will leave first?
At the center, because there will be much more radius,
No, if we consider
more
center,
distance.
let's suppose if you consider center, so that will be close to your center like this. So you can see at this point your radius is very much small, right? And if you consider the next
Yes.
point, that is at the edge. So at the edge we know that your radius will be maximum, right? So we
Yes.
need to choose the maximum radius. So maximum radius will be at the edge of the plate, right? Not at the center.
Yes. Okay.
Because you can see near the center is very short. And if we consider this point, so this is greater. So we can say that mud at the edge first leave the plate because centripetal force with increase in radius. Okay. And we can also use the reference from the formula that your Fc is equals to mr omega square, right?
Yes.
Okay. So at the edge, mud will leave the surface first. Okay. Any confusion?
No.
Okay. So question is a little bit difficult, but slowly, gradually, you will got the concept that how the questions will be in your paper, they will ask in your exams. Okay.
Okay.
If we consider another question, because some questions are related to the gravitational effect also, so that is related to your next chapter also. Okay, we skip this question because that is also related to your gravitational. Okay, question 4. This is the short question. So in question number 4, a particle is following a circular path and is observed to have an angular displacement of 10.3 degree. Now you need to express this angle in radians. Show your working and give your answer to 3 significant figures. Okay. So you observe and you know about the formula, that what formula we need to use. We discussed in the very first topic that if we need to convert degrees to radians, so what we need to do, multiply by pi by 180, and that will give your answer into radians, right? So what
Yes.
we need to do?
So we'll just do 10.30
Hmm.
multiply by pi over 180.
Okay. So according to the formula, you can see that pi by 180 multiply by the given theta, right? That is 10.3. So you can find,
0.17.
you are getting 0.17.
Yes.
Okay. So that is your answer, 0.17. Okay. And they are asking about your answer in 3 significant figures. So there are only 2 significant figures. So any other
Okay.
value that in the calculator?
0.179.
So basically that is 0.179. So we just round it off. So you will get 0.180,
8.
right? Now we have 3 significant figures towards the right. Okay.
Yes. Okay.
And the next part is determine 10.3 to 3 significant figures. So that is from your calculator. You just need to write 10.3 in your calculator and just find out the value to 3 significant figures.
1.197. And this will
1.197.
be, yes. And then this will be um 1.120.
Into radians. Okay, let me calculate and let you know. We just calculate first the 10 value of 10.3. Okay, so 10, 10.3. So it is equals to 0.1817. Okay, so this is the value. Okay, and we need to round it off to 3 significant figure. Maybe your calculator is converted into other degrees, so check that. You just need to type 10 in calculator and write 10.3. So that will give you answer 0.1817 and so on. But we need to round off for 3 significant figure, so that will be equals to round off 0.8182. Okay, because 7 round of the previous letter digit, that will be equal
Okay.
to 0.182. Okay, now you can see that in our angle we find the value 0.180, but according to 10.3 we find the answer 0.182. So in next part we are asking, hence calculate the percentage error that is made when the angle 10.3 as measured in radians is assumed to be equal to 10.3 because initially we convert into radian and after we calculate in degree form. So we are getting almost same answer, but there is little bit difference of 0.002. So they are asking about to calculate the percentage error. That is the topic from your AS, right?
Yes.
So what we need to do, we can calculate percentage error. 0.02 is the difference, right? Divided by the value. We can
0.182,
radian. No,
180.
0.10 rest because we need to find out the value in radians, right? Our main concern is to find out the
Okay.
values radians. 0.182 is in degrees, right? So that's why we first find the difference and then divide the two values and then finally multiply by 100. So what will be your final answer now?
1.11.
1.11. So that is round of 1%. Okay.
Yes. Okay.
So there is 1% error in your answer. Okay. So this is related to the photon in magnetic field. Okay. Question number 3. In question number 3, the orbit of the sun, the orbit of the earth, the mass of the earth is given as 6 into 10 to the power 24 kg, may be assumed to be a circle of radius. So radius is given. This is the mass. This is the radius at the center. Now the time taken for one orbit is, this is the time to take by the one orbit. Okay. And they are asking about to calculate the magnitude of the angular velocity of the earth about the sun. So they are asking about the angular velocity, or in simple word we can say that angular speed. So if you remember again the formula, so angular speed is equals to 2 pi over t, right?
Yes.
We can also write it as 2 pi f according to the values that was given in the question. So we know that a time is given. So we use this formula, omega is equals to 2 pi over t. So first part is very easy. The value of t is equals to this, right?
No problem.
Okay, so basically we just find out the velocity in the first part, right? That was the easy one because we just need to use the formula and plug in the values in the formula and you will find out the final answer and you will get your final answer.
Yes. Hello.
Yes, so what will be the final answer of this part? You will get answer around 1.96 something.
Check.
I'm getting this
Yes. 1
answer.
point.
Okay.
Yes. Same.
Okay, so this is the answer, and you know that now we already have the units written in the answer, so we don't need to learn about that much more. The next is the magnitude of the centripetal force acting on the earth. So now you need to calculate the centripetal force. Okay, so before starting or before using any formula, just find out the available quantities in your question, right? Just like in the previous question, we know that centripetal force is equals to mv square over r, but there is no concept of linear velocity there. So that's why we use the second formula mr omega square, because we are using angular terms, right? So in this question,
Yes.
we go with the same because we've already find out the value of omega. Okay, so omega is already there, and we are having a value of capital T, that is the time period, plus we are also having a value of r plus m. So now you got the hint that which formula is easy to use in this question. F is equal
Yes.
to mr omega square, right?
Yes.
So at initial stages, questions are like difficult one, but you need to solve like this. Just keep all the formula, all the concepts in front of you or your notebook, and then try to understand that which concept is going to be applied, because they mention the centripetal. The centripetal force, you just take the reference from all the notes from the centripetal force, and then try to apply the information that is relevant to the question, right? Just like we just find out the values, the quantities, because centripetal force is actually equals to, either it is equals to mv square over r or mr omega square, right? So we found the values mr omega square, we found all the things. So then we just use the values mr omega square in this question. Okay, so your final answer will be equal to the multiplication of all the things. So basically m is 6 exponent 24, r is 1.5 exponent 11, omega is 1.9 whole square. Okay,
Yes.
so just multiply the term, you will get the value of force. Or you can also do that like that, 6 multiply 1.5 multiply 1.96, then combine the exponent values, because we know in multiplication we need to add them. So you can also use that concept. Okay,
Yes. Is it 3.45
okay,
multiplied by 10 raised to
okay,
the power 22?
okay. And what are the digits after 4, 5 and
7.
7? So what you need to do, you need to round off the value.
457.
4 5, no, 4, you just mentioned 3.457, right? So we need to round off 5. So it will be 3.46. Okay. 3.46 exponent
Yes.
d2 Newton. Okay.
Okay.
So this is the concept.
Okay.
And the next is state the origin of the centripetal force calculated in a second point. So basically, that we are using the concept of the force of attraction between two planets, right? And when we are talking about two planets, so basically there is a gravitational force or gravitational field strength, right? Because sun is actually attracting the earth, because the mass of sun is greater than earth. So earth is revolving around the sun, because sun is attracting the earth, right? So they are asking about the origin, because normally we talk about thread and stone. So thread is the source, right? That is connected with the stone. So basically thread provides the centripetal force to the stone. Okay. But in this situation, there is a concept of gravitational force or gravitational field strength that help us to move the earth in a circular path. Okay.
Okay.
We will also discuss this concept in the next chapter of gravitation, but this is journal one. So that's why I'm writing for part one in question B, because that is only for 1 mark.
Okay.
So gravitational field strength. is the final answer. Okay, and we will solve this part 2 after doing second chapter, that is related to gravitation, right? Because we need to know about the formula for gravitation. So that's why we will not solve this question right now. We will solve this question after completing chapter number 2. Okay.
Okay.